Okay, we are recording. Once again, hello everyone. Welcome to the day 3 of our Forge training bootcamp. Today, talking about extending the Forge viewer. My name is Peter Bros. I'm a former developer of the Forge viewer component, and now I'm a Forge developer advocate with it, which means that my job now is to help other developers leverage the Autodesk Forge technology, in my case, mainly focusing on the viewer. So I'm really happy I can guide you through our viewer extension tutorial today. Again, I'm assuming that most of you have gone through our day 1 and or day 2 trainings for either Node.js or .NET. But if not, let me tell you very quickly about the format of this event. Since we cannot meet with you in person, face-to-face, let's say at Autodesk University or other live events where we could have a hands-on lab coding experience with you, we're trying to compensate for that by running this Forge training where we basically, throughout the day, we run through a couple of live demos where I code parts of a tutorial, and then I ask you to follow along and follow my steps and implement the same thing. And if you run into any problems, I'll be there. I'll be here to help you out, to make sure that you can actually go through the whole tutorial and build something with Forge. We will be following a tutorial from our LearnForge website, the learnforge.autodesk.io. And again, view your models or view BIM 360 Fusion models were the tutorials covered on Monday and Tuesday for both groups, on .NET and Node.js. And today we're looking at the viewer extension tutorial here, which basically doesn't really care what kind of programming language you're using on the server side. We're going to assume that you will have one of those apps from Monday or Tuesday available, or if not, if you're here for the first time this week, I'll show you how you can get one of those apps that were built in the previous days. You can get a complete source code of that app and just get it running on your machine. All right. And what we're building today specifically, it's going to be 2 extensions for Forge Viewer. So Forge Viewer is the one component from the offering of Forge that is not a server-side, a web service or RESTful API. Forge Viewer is a JavaScript component, JavaScript library that you can use on your website, on your webpage, to preview content extracted from your designs by Forge. And that includes 3D geometry, 2D drawings as well. In this case, we'll be building a couple of extensions for the viewer because the JavaScript library itself provides mechanisms to extend it so that you can add additional functionality into the viewer. You can add custom buttons into the toolbar. You can add custom UI, custom panels. You can customize the behavior of the viewer, modify the visualization of the individual elements in your design in the viewer, things like that. And we will go through some of those here. We will build an extension that will basically take a look at anything you have selected in the viewer. It'll read this information from the viewer using its APIs, and it'll isolate those elements also programmatically. And we will build another extension that will actually create a new UI panel showing some custom information that you might want to show in your own Forge apps. The agenda, same as Monday and Tuesday, we will have 4 segments, 2 hours apart, starting with the one right now. First of all, we'll go through the basic setup. That here I'm just going to show how to get one of those, the source code for one of the apps from Monday or Tuesday if you are here for the first time, if you don't have an app running already. If you were here with us on Monday or Tuesday, definitely we encourage you to continue working on that application. But again, because today we will be working on the client side. So it doesn't really matter where the geometry, where the content to the viewer is coming from, right? If you want to use your app accessing your BIM 360 content or A360 content, or if you want to use your app where you are uploading your files to your bucket in the data management service app yourself, that's totally fine too. Or maybe if you have a completely different existing Forge application, maybe your production app, and you want to start experimenting with the viewer APIs in that environment, that's totally fine as well. Then 2 hours later, we will regroup here. I will review your questions if you have any, if you run into any problems. And then we start actually implementing the extension skeleton. So as part of the second segment, we will build a skeleton for an extension that we will then reuse in the additional the third and the fourth step. At 1 p.m. of Central European summer time zone, we will again review your questions and look at the different viewer APIs that work with the selection and isolation, how to react to events and that part of functionality in Forge Viewer. And then finally, at 3 p.m., the fourth final part, we will again review your questions and we will take a look at how the viewer APIs allow you to add the custom user interface, like docking panel, for example, or again, like toolbar buttons, and we can take a look at some of the advanced viewer APIs as well if there's time. Along the way, if you have any question, please let me know. You can ask in the Q&A section. So in your Zoom toolbar, you should see a Q&A button. That's where you can ask your questions and I'll try and answer them as soon as I can. I have my 2 screens here, so I'll be monitoring the Q&A. You can also raise your hand in Zoom, but that I cannot guarantee that I'll see that because we've got quite a lot of people here and you don't fit on my list here. So I might miss that. So if you have any question, you can raise a hand as well. I'll try and pay attention and monitor the participant list as well, but I would recommend that you use the Q&A or the chat instead. And this also applies for the time for the breaks between the sessions, right? As you are following my steps, what I had shown in a live demo. If you run into any problem, drop me a note in the Q&A, and again, I'll get back to you as soon as possible. All right, so time for our first step, intro and setup. So by now, again, I'm assuming that you all have a Forge account already, some Forge subscription. Even the trial subscription one is fine, and that you have a Forge application. And again, very quickly, for those of you who may be here for the first time, what you'll want to do if you don't have a Forge account is simply go to our portal, to the forge.autodesk.com. And here you will see, if you're not logged in, you will see 2 buttons, sign in or sign up. If you don't have a Forge account yet, just hit the sign up button. It's free. And then you will see an option, a button to start a trial subscription if you don't have one already. And what that will do is that will start a new Forge subscription for you that will give you some starting currency we use in Forge called cloud credits, because the Forge platform, the pricing model is basically consumption-based, meaning that you only pay for what you use. And if you create a trial subscription, you get 100 cloud credits that can be used towards all the different services that you're using along the way. Some more details about how much it costs to, for example, translate one of your models, one of your designs for the Forge Viewer is explained in the pricing section at the end of the top menu. All right, now I see a raised hand, Henri. Okay, let me unmute you if you have a mic, if you wanna ask a question. Or if not, you can ask in the chat as well, or in the Q&A. Okay, so there we go. Chat. Oh, wrong button. All right. All right. So we can proceed. Oh, one more raised hand. Oh. All right. So yeah, so you'll be able to, you'll get 100 cloud credits. That is more than enough to start experimenting with Forge and building your first Forge apps. Once you're done with that, when you log into Forge, under your profile menu at the top right corner, you'll see My Apps section. This is where you can start creating something called Forge apps. Forge apps are really nothing else than just individual records containing some credentials, client ID and client secret, for whenever you want to communicate with the Forge services. So you always have to authenticate somehow that you are who you say you are, and to do that, you just need to create an app, provide. Let me actually hit the create app button here. You just provide a, you choose which APIs you want to work with. Here, I would recommend checking everything. And then you provide your app's name and short description. And then finally, your website URL doesn't have to be valid. So if you don't have any public domain where your app will be running, and this is just experiments, you can just say foobar.com here. It's totally fine. The callback URL is important if you want to build an app that is somehow working with third-party products built on Forge, such as BIM 360 or Fusion Teams, for example. In that case, if you assume that in your application you will want your users to be able to log in with their Autodesk credentials, in that case, you would have to specify a valid callback URL that Autodesk will redirect their users to after they sign in successfully. If you want to learn more about how this works, I would refer you back to the tutorial we covered yesterday. That's the View, BIM 360, and Fusion models on the Learn Forge website. And that's it. And when you create your app, you'll get client ID and client secret. And that really is the two critical pieces of information that we always need to have available at hand, because these are the sort of like the username and password you're going to be using to authenticate yourself with whenever you're communicating with Forge, right? Whenever you're building your server-side logic, whether it's using Node.js or .NET or Java or PHP or Python or whichever language, you'll always want to use these two strings to basically generate an access token from Forge, and then using that access token to communicate with our services. So make sure that you have an app created and that you have these two values available at hand somewhere, because we're going to use them soon. All right. Now for development environment, here we talk about Node.js, but again, you don't have to use Node.js strictly. Again, the assumption here is that you already have some kind of Forge application that you've built either yourself or with our help on Monday or Tuesday. So if you're building your app in Node.js, or if you're from the other group from .NET, or if you already have an existing application, Forge application built with Java or PHP, that's totally fine too. We just want to make sure that at the end of step one, you will have some Forge application ready, running, so that we can, in step two, we can start extending the viewer on the client side. So here, what I'm going to use throughout this demo is Node.js as my server-side programming language and runtime. And I'm going to use Visual Studio Code for development. Again, you're free to use any other editor you want. I'll be using Visual Studio Code here. And Git for source code management. All right. So for those of you who don't yet have any Forge application to start building on top of, if you if you didn't build any app with us Monday or Tuesday this week, you'll be happy to know that all of these tutorials, all the tutorials on the LearnForge website, including view your models and view BIM 360 Fusion models, modify your models, I believe that one as well. All these tutorials provide a complete implementation for individual languages explained and documented on this website. So for example, if I go to the view your models tutorial, you'll notice at the end that there's a message, there's a note saying if you want to download the project ready to use, you can just go to follow along to one of these repos. They're actually not different repos, they are the same repository, but we keep the implementations of individual languages in different branches in one repo. So what you can do is, if you don't have a Forge app ready, you can just pick your favorite language from the list here. So I'm going to choose Node.js, and that will take you to our GitHub, one of our GitHub repos, where we keep the complete source code of this sample of the View Your Models tutorial. That's the whole thing here. And what you can do here, if you want to get this code or the .NET or .NET Core version to your machine, there are a couple of different ways you can go around that to get the code. You can either clone it using the Git command line tool. That's one option. Or you can simply download and unzip the source code through this link. So if you go to code and download zip, that'll basically get you the entire source code of this specific branch, in this case, the Node.js branch, that you can just get. I'm just gonna save it to my, to my code folder. And I should have a temp folder and Forge training 2020. I'm going to save it somewhere in my local file system and extract it. And there you go. This is our ready to use Node.js version of the first tutorial from the LearnForge website, to view your models. As for the editor, as I mentioned, I'm going to be using Visual Studio Code. So for those of you who may not know, Visual Studio Code is a small, lightweight code editor from Microsoft. It's like a lightweight brother. I keep saying it's a lightweight brother of the proper Visual Studio suite. It's, I think, especially for web development, it's really good, maybe really even better than Visual Studio. It's really fast, and it's got a lot of cool support for, again, web technologies and web development in general. So if you're curious to give it a try, just download the latest stable version for your operating system and install it. And so that's what I'm going to be using here. And by the way, a shameless plug, for those of you who don't know or may not know, we also provide a Autodesk Forge extension for Visual Studio Code. So if you decide to use Visual Studio Code, you can use this extension to basically work with the Forge content and services without writing any code at all, really. You can just immediately start creating buckets, uploading files, translating them, and even previewing them directly inside the editor without writing a single line of code. So I'm going to be using Visual Studio Code in my case. And what I'm going to do is I'm going to open a folder. I'm going to open the folder that I just downloaded and unzipped from GitHub, right? That's the View Your Models complete source code for the Node.js language in my case. So if you want to follow along, this is what you want to do, right? Download the zip file from GitHub and open that unzipped folder with Visual Studio Code to make it your project folder. And now once you're here, what you'll want to do is If you're using Node.js, I will assume that, again, you already have Node.js available in your command line. If not, you'll want to go to nodejs.org and download we recommend the LTS, the long-term support version of Node.js, which is the version 12.19, and install it to your machine. After that, in your command line environment, you should have two commands available. One called node. If I type node-v, I should see a version 12 something, and you should see another command available there called npm. If I run npm-v, you should see some version there as well. npm is the Node.js package manager. That's the tool used to manage third-party dependencies for your project, so installing them and upgrading them to newer versions and things like that. Now, what happens here, you can see we already have our source code available. Some basic Node.js app, again, the one we actually built on Monday with the Node.js group. But if I simply try and run this app, it won't work, because I say something like node start.js, I'm going to get an error, module not found. And that is because in the package.json file, this is like the main manifest file describing our Node.js project, we actually specify a couple of third-party dependencies that we require in order to run our project, our application, right? So what we could do is just type in the command line while inside our project folder, just type npm install. And what this will do is the npm tool will look inside the package.json. It'll take a look at all the dependencies specified there, and it will install them into your project into a subfolder called node_modules. So let's do that now. We get 3 dependencies installed in, let me refresh, into node modules subfolder. All right, now if we try and run the app again, it will still not work, but now it will yield a different error, and that is missing Forge client ID and Forge client secret, right? So for both groups, whether you're working with Node.js or .NET Core, .NET, Java, PHP, you always will want to specify somehow Forge client ID and Forge client secret. Those are the 2 values you see when you create your Forge application here, right? Again, and whenever you're building a server application that is supposed to talk to Forge, you will somehow want to pass these 2 strings to your app so that the Forge SDKs for your specific language can actually authenticate themselves to Forge. In this case, since we're using Visual Studio Code, we could either, we could specify the environment variables in the command line, either if you're using a bash or bash-like terminal, you could say export Forge client ID equals your ID, and then Forge client secret equals your client secret. But since we're using Visual Studio Code, we will actually configure these environment variables in something called a launch configuration. So if you're using VS Code and you want to set up your app for debugging, you simply go to Command Palette. I'm not sure what the shortcut is on Windows. So just go to the View menu and find the first item there, Command Palette, and look for Launch. And find the command called debug open launch JSON. That's one option. Or you could go to this 4th icon in the sidebar, where you will eventually want to run and debug your application from. And you'll see that there is nothing configured yet. So Visual Studio Code doesn't know how exactly you want to run your application. So from here, you can say create a launch JSON file. When you do that, you'll get a list of options of runtimes that you want to set up your debugging for, right? So in this case, we are running a Node.js app, or in my case, so I'm going to choose Node.js. And I have some basic JSON set up here. You see that we have one configuration called launch program, which will use Node.js to run a program starting with the script start.js. That looks good, right? Because we're in our workspace folder, and that start.js is exactly the Node.js file we want to run as our Node.js server. So we can leave that as is. And then we can start adding additional properties to this JSON, and VS Code makes it relatively easy to modify these JSONs because it's providing IntelliSense for the different properties you can add in those JSON structures as well. So if I start adding new property, you see I have a couple more options. I can specify, for example, arguments passed to our application by the OS, or I can specify environments. So one option, I can specify the env property, which will be simply a dictionary of environment, variable name, and value. Or I can say env file and specify a path to a file that will contain all my environment variables, right? So right now, by default, this launch configuration will be looking for a file in our same workspace folder called .env. So we can create it here, create .env file, and we can start specifying our environment variables here, right? So let me just go back to my Forge app. And again, by the way, you should never share your client ID and client secret with anyone, because with that, you're basically giving people the option to start communicating with Forge, pretending to be you, right? So I'm doing that here to show you how to set up the environment, but what I'm going to do later on is, in your Forge app, you have an option to recreate the client secret. So, just to be safe that, nobody steals my client secret, I will regenerate the client secret later on. And also, when you are about to, send your code to GitHub, for example, you should never include, in this case, the .env file to GitHub, right? Because you don't want people to have access to your Forge client and client secret. So what that means is, if I were to start sharing, sending my code to GitHub, what I recommend doing, or what you should be doing, is include a .gitignore file and specify files you want to exclude from being sent to GitHub, and .env is actually included there as well. So that's good, right? So you can see here in Visual Studio Code, the .env file is grayed out, which means that this file will not go to GitHub. All right, and with our launch configuration ready in this .vs Code subfolder, you should now be able to go back to our debug or run section in the sidebar, and we see our first configuration here called launch program, right? And we can run it. And here we see the output from the console. So our server is now ready and listening on port 3000. So we should be able to go to localhost 3000, and we have our complete Forge application ready, ready to start extending the viewer side, the viewer component. Let's see. Yeah. Okay. There we go. All right. So this is how you can set up a Forge application, complete all by basic application from scratch, in case you don't have one yet, so that we can start working on the viewer piece in the second step. All right, that was our live demo. Okay, are there any questions? Okay, I see there is one. Okay, there's a question. Noticed in your .env file, you didn't include double quotes around your ID and secret. Is that correct? I believe so. I think as well, that would be probably an implementation detail of Visual Studio Code specifically. I never include double quotes here because I don't use spaces or anything else in these environment variables. But it is, I assume that if you wanted to include spaces, for example, well, maybe even not with spaces. This is probably just, each line is a equal sign separated key value, right? So for example, if I wanted to add another environment variable called, let's try that. I'm losing my mouse cursor. All right, so I have my new greetings environment variable, and I'll want to greet myself in our start.js file, for example. And so I'm going to say console log process.env, accessing the greetings environment variable, right? And if we try that, there you go, hello world. So you don't even have to specify double quotes if you have like spaces in your strings, in your environment variable values. So no need for double quotes there. All right. One more question. Can we stay on the .NET Core example from the 2 previous days? Yes, absolutely. As I said, you are encouraged to use any Forge application to use today, whether it's maybe your production Forge app already, or whether it's one of the apps you built on Monday or Tuesday using .NET or Node.js, whichever, right? It doesn't really matter because again, today we will be working on the client side, extending the Forge viewer, and it doesn't really matter that much where the models are coming from into the Forge viewer. So it can be any app, .NET, .NET Core, Node.js, PHP, up to you. All right, PowerShell. Okay, and again, maybe for the .NET Core or .NET and .NET Core group, I'm curious if you could type in the chat, what kind of environment are you using for .NET Core development? Are you using Visual Studio proper, or are you using Visual Studio Code as well? If you could type it in the chat, I'm just curious. Or maybe we can do the raised hands. Can you raise hand if you're developing .NET Core and using Visual Studio proper? Okay. All right. And thank you. So let me lower all hands. And can you raise a hand if you're developing .NET Core using Visual Studio Code? All right, a couple. Cool. All right, thank you. So just again, shameless plug, side note, for those of you who are now maybe using VS Code for the first time, if you go to the extensions section here and search for Autodesk Forge, you'll see an extension here with the Forge logo. This is the one I was talking about earlier, the extension that will basically give you access to various areas of the Forge platform without any coding. So you'll be able to, again, create buckets, upload files, download files, translate them, preview them, manage your Forge webhooks, or even work with the design automation service. So when you want to upload new bundles or define a new activity, or actually run some job in AutoCAD or Revit or Inventor or 3ds Max, you can start the job from within here as well. So give it a shot. Might find it useful for any Forge experiments. What it looks like later on when you install it, you'll get this new Forge logo here in the sidebar as well. If you're running for the first time, it'll ask you for some basic, for some configuration, right? Because again, in order for the extension to be able to talk to Forge, it needs to have some Forge credentials, the client ID and client secret. So if you're running for the first time, it'll ask you if you want to enter your Forge credentials. And if you say yes, it'll just guide you through like enter your Forge client ID, enter your Forge client secret, choose a data region, meaning where you want your Forge data to be present physically, if it's in the US, geo, or in EMEA. And then you just enter a name for your Forge environment, because you can have multiple environments and you can switch between them through this item here at the bottom in the status bar. So I only have one environment. I call it Forge Training 2020. If I had more, I would see them in a list here and I could switch between them. Right, and with that, I can start exploring my content in Forge, my buckets, to see what files were uploaded there, what viewables were extracted from them by the model derivative service. I can preview the 2D drawings or the 3D views inside the viewer, inside Visual Studio Code. Or I can, get the JSON representing the entire scene tree as well, if that's something maybe you want to work with. This one might be a bit more complex, but okay. Or preview the 3D as well. All right, so let's see. 2 more questions. All right. I see a question here from Andre. I'm not sure if that's a question. Andre, could you maybe explain a bit more if there's something you want to ask? In the meantime, another question, could you tell us again how to get access to the recordings from the 2 previous days for Node.js? Yeah, so again, we won't be sharing the links to these recordings officially, because again, I don't think they will be very good quality for like actual learning experience. But if you do need to get access to those recordings for some reason, if you missed one part or there was something specific you wanted to check, just ping us through, type it here, through our official forge.help@autodesk.com, or you can ping me directly email or a Twitter handle. So just let us know if you need access to any of those recordings. And I was already sharing the recording of the Monday Node.js part with one of the attendees, because they missed one part of the live demo, so they just wanted to double check. So just let us know, and we'll get you the links to those recordings as well. All right. And unless there are no other questions, we now have 1 hour and 20 minutes until we meet again and we start working on the Forge Viewer part. So good luck. And again, let's make sure that when we meet at 11 a.m. Central European time, that you have a Forge app running and ready to start, building on top of. All right, so I'll see you then. Okay, we're back. Welcome back, everyone. We're moving on to step 2. We still have a little bit of time. If you want to ask any question, bring up any comment about step 1 and getting your application ready. And so by now, again, you should have Forge account and subscription ready. You should have a Forge application with client ID and client secret. And those of you following exactly my steps, that Visual Studio Code installed and your project cloned or copied from GitHub and configured them up and running. All right, step 2, we're going to start adding viewer extension, implementing our first viewer extension. Before we get to that though, okay, so here's our live demo queue. Why why doing viewer extensions? So a bit of a side note for some of you who may be very new to Forge development and Forge viewer development in the first place. The JavaScript library, the Forge viewer, right? The JavaScript component based on WebGL, the component that actually renders your 2D drawings and 3D models on a web page, exposes its own set of APIs, JavaScript APIs that you can work with. You can find more information about the Forge viewer APIs when you go back to our Forge portal to the documentation section. And at the bottom, you'll find viewer part. And if you go to the API reference, just like for the other services, you would find the documentation for the individual endpoints for the different REST APIs that you can call for those services. In case of the viewer component, the API reference will include the actual documentation for the JavaScript classes and methods available, exposed by Forge viewer. The most important one is in the viewing namespace called Viewer 3D. This is the one we're going to be using most of the time. This is the main class, providing all the, well, most of the standard APIs that allow you to somehow programmatically interact with the viewer, allowing you to do things like get the list of IDs of objects currently selected by the user by calling viewer.getSelection, or allowing you to, let's see, to programmatically select specific objects by providing a list of their IDs, or isolating specific nodes, right? So all sorts of things, or setting theming color to individual objects. So all these APIs are available to you when you're building your application based on Forge viewer, and when you want to customize the experience in some way. So one example I was showing yesterday was the Forge digital twin demo. That's one of our demos, one of the official demos we've built to demonstrate the capabilities of Forge viewer mainly. In this case, focusing on the use cases around IoT or digital twin. So in cases where maybe you would want to combine the visualization of your designs with some real-time data, or maybe even customizing the viewer visualization itself by, for example, coloring individual elements of your design based on certain metrics, or by embedding additional information. You can add custom 3D geometry into your scene, or overlay your viewer with additional HTML content to maybe give some annotations attached to different elements in the design, or you can animate stuff, parts of your design as well. So all this is basically done using the viewer APIs. And one cool aspect of this client-side JavaScript development that I'd like to bring up, something for you to experiment with, right? When you're ready to start using the viewer APIs, when you just want to get feel for what's available there, what it can do. One cool aspect of the JavaScript development, client-side development, is that the JavaScript class for the viewer, right, the one that we've been looking at, I'm sorry, I closed it. The API reference, all these methods available on the viewer 3D class. Wrong documentation. Give me a second. Here. All these methods, you can actually call these immediately from inside the console in your browser for a currently running Forge application. So you don't even have to go through, adding code, reloading your app, testing something during runtime, then going back to your code, modifying the code, reloading your app, going back to runtime again. So instead, if you have your app running already, or maybe I could just use the app I have downloaded from GitHub. Okay. If I go to localhost 3000, right? So this is my basic Forge app. And what I can do here is whenever you create a new instance of Forge Viewer on your website, we actually store this shortcut little global variable called NOP_viewer that points to that instance of viewer 3D class. And you can use that from the console here. So if I type NOP_viewer, all uppercase, you'll see that that's the instance of our Forge viewer. And all the methods I was showing you earlier, things like get selection, select or isolate, or get set theming color, I can call all of these during runtime without even having to go back to my code and reload the entire application, right? So what I can do here is I can say, for example, if I select a couple things in my design and I go back to my console and say NOP_viewer.getSelection, you see that it'll return an array of two numbers, right? That's the IDs of the two things, two parts I have selected in the viewer, right? And we can take it the other way around, and I deselect everything and I say NOP_viewer.select. I can pass in 2213 and 4045 to select the same objects programmatically, right? I can also say NOP_viewer. For example, get properties. And I pass in one ID, so I'll try the first one, 2213, and I provide two callback functions, one to be called in case of success, so I'll use this console log, and another function to be called in case of an error, so I'm going to say console error. What happened here is that the viewer actually went into its data structure that's currently sitting in memory, containing all the metadata extracted by Forge, attached to individual objects in my design, right? So the result that we got here is that basic roof, and we've got 44 properties available programmatically, right? So we can start, what we can start doing is, getting properties of different objects in the scene loaded in Forge Viewer, read their properties and maybe color them depending on something, maybe depending on their phase, right? So if they're planning, currently, I don't know, in this, if they have the status of like about to be built, we can color them differently. If they're being built, we can color them differently. Or if they have already been built, we can give them a different color again. And the way we could do that is by using another API, another method on the viewer 3D object called setThemingColor. setThemingColor, I once again provide the ID of the object I want to color, and then I provide a four component vector providing the RGBA. So I can say maybe 0 for red, 0.5 for green, and 1 for blue, and 0.5 for the intensity, how much of the opacity basically of the theming color applied. And if I do that, you see that I've now changed the color of our roof. So all this stuff, you can experiment with it without even having to, go through the development cycles, like editing something in your code, reloading the app. You can just play with it right here during runtime, and then when you find something you want to use in your code, you can then bring it back into your code editor. So that's about what the viewer APIs can actually do. This is just a tip of the iceberg, but just to give you some idea of what's possible there. Now, what you could do is you could start adding this logic, like to getting properties of objects and coloring them based on some criteria, or hiding things or isolating things or adding custom geometry. You could start doing all of that in your JavaScript code whenever you instantiate your viewer, right? That's okay for small projects and experiments, but later on, as your application code grows, that could be a bit tricky to maintain, right, down the road. So what we recommend is actually encapsulating any custom functionality that you're building for your Forge Viewer application into an extension, right? That'll have a couple of benefits. One of them being, that code will know exactly what instance of viewer you want to use, because in some cases, if you had multiple instances of the viewer on the same page, you would need to keep track to make sure that your custom code is actually talking to the right viewer. Then having, wrapping your custom functionality into an extension also gives you the benefit of getting notified of various lifecycle events for the viewer itself, right? Because when you're developing an extension, you will get notified when, for example, when the viewer is loaded, when your extension is loaded in it, or when a toolbar is created. That's something we're gonna leverage later on. Then I think the most important benefit of implementing your custom functionality inside a viewer extension is that, that functionality, self-contained functionality, can then very nicely and easily be shared with, other teams in your company, or, with and reused in other parts of your website, right? So you may have another web page where you have Forge Viewer as well, and maybe you would like to reuse the same custom functionality in that viewer instance. So instead of just smashing the custom code somewhere in your JavaScript file that is only specific to this web page, you can have an extension that will then be reused in other places as well. All right, I see we've got a couple of questions. Can we do transforms? I may need a bit more info on that, on the question. If we're talking about transforming objects in the model, we can quickly demo that as well, if that's what you're asking for, Gareth. Scale, rotate, move. Yes. Okay. Yeah, we can touch on that as well. We'll see now if we have time at the end of this segment. All right. Another question? Does the change properties in the JSON or just a virtual rendering in the browser? So I guess, Gabriel, you're referring to changing the color of elements. Okay, this does not actually make any modifications back to the data extracted by Forge, because the file format extracted by Forge from your designs, it's called SVF. It's a proprietary format really optimized for viewing on the web, and it's meant to be loaded in Forge Viewer. You can think of it as a PDF, right? It's a highly portable, efficient format, but not really made for any edits, right? So it's not like if you get a PDF you got from, let's say, a Word document, you do have some flexibility of changes you can make there, but it's really meant to be the final baked viewing format, right? So what I did in here when I called a set theming color, this is only changing the color, the state of this instance of the viewer. So if I reload this page and load my model again, the roof will be back to its original color. So these APIs, they only change the temporary state of the rendering that you're working with. Then if you actually were interested in something like actually maybe making some kind of changes that are then projected or applied back to the original model, that is something you could do as well, but not just with the viewer, right? What you would need at that point would be the design automation service in Forge. That's the service that can actually, where we can run Revit, AutoCAD, Inventor, or 3ds Max on our servers and run your custom plugins there, right? So you could imagine if I do some changes here, maybe I would like to have some sort of a configurator experience where I can maybe change the color of the walls, change the material of the roof, and something like that. Doing it here in the viewer will only really just change the appearance in this rendering, this temporary state. But then what you could do is you could collect information about all the changes that your user did, right? All the changes of, if I change the color or material of the roof or change the size of a window here, you could then collect these changes and send them back to Forge, to the design automation service. And that design automation service could then read the original Revit file that was used to generate this SVF. It could apply those changes using Revit APIs. And then you could basically create a new version of your Revit document with the changes applied inside Revit. All right. Cool. No other questions, it seems. So we can go back to our code. Okay, and as I said, again, it's really a good idea to wrap your custom viewer functionality into an extension. And now we're going to take a look at how we can do that. Right, so you have your Forge application ready. You most likely have some static assets, some JavaScript, CSS, and HTML files that you're accessing from the browser. Maybe one more question. Is there a way to get the dimensions of a selected element? Good question. So let me run the app one more time. Here, maybe load it. So getting some kind of information about the selected element. So let's say I choose this wall, and I'm going to say viewer.getSelection. So 2590 is the ID of this wall element. And I'm going to say get properties 2590 console log console error, right? So if you're interested in specifically getting dimensions of an element in the viewer, there are a couple of ways, right? If you do know that maybe you're working with a design format like Revit, where this information is included in the properties for that object, that's easy, right? You just ask for its properties. And in case of Revit, you could theoretically find some dimensions data there, or maybe not. Well, you do. You have like you have length. You see here an area, and all this metadata that Forge was able to extract from that input model, right? If you know that you're working with models, designs where this information is included in the metadata, that's easy, right? So here's your information: length. So basically, all these properties, by the way, just a side note, are the same properties you see when you use this icon in the toolbar to look at the properties of that element, whatever is selected, right? So if I'm looking at this basic wall, there's going to be a section called dimensions, right? So here I see length, area, and volume. And all these properties are basically coming from the same API call, right? So under the hood, if you open this window, Forge Viewer will just make the same get properties call to retrieve properties for this one selected element, and it will present them to you in this property view, right? So that's for a case where the dimension data is available in the metadata. If it's not there, that could be the case for other, like maybe some simpler file formats, right? If you had like maybe a step file, and if you import a step file into Forge, you may not see this kind of information, the metadata, right? Because this metadata is specific to Revit. And in that case, you have a bit more functionality available there at your disposal. What you could do is you could actually ask for the bounding box of the actual geometry used for this wall. And to do that, you would want to use something called fragments. So every single object in the viewer, every single piece of geometry is called a fragment. So fragment represents a piece of geometry placed at a specific position with a specific material applied to it, right? So one thing we could do is we could get a fragment list using NLP viewer.model model is the actual design loaded into the viewer, that get fragment list. And this is a special structure fragment list that we can then use to set or read different information about the individual fragments. Now we also need to know, because this one wall may actually consist of multiple fragments, because there is one too many mappings between an object and a fragment. Because, for example, if I select a window here, you can see that it actually consists of the frame, which has a certain material, and then it contains the glass, which is a different material as well. So this could actually, this one selectable object could consist of two fragments, one for the border, one for the frame, and one for the glass. For the wall, we'll see, in order to be able to find out which fragments are connected to this object, or which fragments this object is made of, we will need to get another helper structure called instance tree. And we call it in a similar way by an OP viewer model, get instance tree. When we do that, we can say get instance tree, enum node fragments. That's one of the methods available on the instance tree, where we can provide an object ID. So in this case, I'll take the wall 2590, and I'm going to use console log to output all the fragments, or we can say, I don't know, frag ID, console log frag ID. So we see that this wall actually is made of 3 fragments with IDs 43, 44, and 79. So now what you could do is you could start using the fragment list to do things like, when you look at the frags, that's the instance holding the reference to our fragment list. You can do things like calling get world bounds, and you can get world bounding box for the individual fragments of this wall, and then by combining the bounding box, you would get the complete bounds dimensions of this wall element, right? So one thing I think I'll need to do is create a new bounding box object, which is an instance of the Three.js class box 3. And now if I say frags get world bounds for, let's say, fragment 43, and I want to store it, this one, no, get world bounds, let me check. Let's use a different syntax. Boxes, world bounds, undefined. Oh, that's because the box is not defined. Okay. Box 3. Okay, now it's defined. So if I say get world bounds 43 box, all right. Now a bounding box variable is populated with the bounds of this one specific fragment. So what you could do is you could compute the bounding box for all the 3 fragments and do their union, and that would give you the dimensions of this wall as well. That's another approach. All right, can we get instance node by fragment? Select glass, get window, instance objects. Okay, so you cannot really select fragments. Fragments are not meant to be the smallest selectable unit. Objects are, right? And this is again because in different designs, you may have a piece of an object being a door, and you want the door to be the smallest selectable element of your design, but that door can actually consist of the wooden frame and, let's say, the steel doorknob, right? So the viewer does not allow you to go all the way down to fragments to select them. It's actually up to the Forge translation, the model derivative service, how it decides to, where it decides to, draw the line. So if the Revit extractor available in Forge, when it takes a Revit model and it outputs elements into this SVF file format, if it finds a door, it'll actually mark the door as an object made of multiple fragments. But the translator, the extractor, will decide that the door is the smallest selectable thing. So you can't really select fragments, individual fragments. Okay, what is the syntax structure of config parameter in new viewer? Okay, we will get to that very soon. Yeah, as we're working on our extension. So let's get back to that. All right. So what we're going to do first, we're going to create a new JavaScript file. We can put it into, in this case, since we have our public folder with a JS subfolder, I'm just going to create a new JavaScript file here. Can be named whatever you want. To be consistent with the LearnForge tutorial website, I'm going to say my awesome extension.js, all lowercase. And this is where we're going to start implementing our first viewer extension. The way we do that, we subclass a class from the Autodesk viewing namespace called extension. So we're going to create a new class, my awesome extension, and it will extend and one of the classes from Forge Viewer called Autodesk viewing extension. All right, this is our first extension. Yeah, you're welcome, Matthias. All right, it's not doing much for now, so let's make it a bit smarter. There is a little bit of boilerplate that is required whenever you are creating an extension. First of all, some constructor. A constructor should have two parameters, viewer and options. This is because when Forge Viewer loads your extension, or when you ask the viewer to load your extension, the viewer will instantiate it by itself, and it will provide its own instance and some additional, potentially, additional config options there. So this is the standard way of having these two parameters in your class's constructor. First of all, we want to call super to basically run the constructor logic from the Autodesk viewing extension class. And here, for now, you don't have to do anything else. Here, this is the time where you would maybe want to specify additional parameters, properties on your extension class or object. Beyond that, there are a couple of function methods that you do want to use, and that's methods like load and unload. These are the methods that will be called by Forge Viewer whenever your extension is loaded or unloaded. So this is the time where you may want to handle some special initialization or de-initialization logic, because one thing to note here is that these unload load methods will also be called, for example, when your user, when the Forge Viewer is actually removing one model and maybe loading another model, right? So this is one of the benefits that I was talking about earlier, where by having by implementing an extension, you will be able to tap into the different lifecycle events. So for example, when a model is unloaded, you will get notified of that. So what I usually do myself, I'll just add console log and say something like my awesome extension loaded, or my custom extension is unloaded. One thing you want to do in these load or unload methods is returning a Boolean flag representing the status of your load or unload, if it's been successful or not. So I'm just going to say return true in both. One more thing is you have an option. If, for example, you need to handle some asynchronous setup in your load or unload methods, you can also return a promise instead of that resolves into a Boolean eventually. So you can you could even say, you could run some async method and then later on return true, and you could have this method be async. That let's leave it at that for now. Now, by implementing this extension code itself, isn't gonna work because we need to, first of all, we need to make sure that this source code makes it to our HTML. So we need to import or link this script file, this my awesome extension, to our HTML. And also we want to do that somewhere after we've imported this viewer3d.js or viewer3d.main.js, because this is the script file that will actually define the class called Autodesk Viewing Extension. So what we're going to do is somewhere at the bottom of our head element, we will add another script to JS with the address js/myawesomeextension.js. So with that, we make sure that this code actually makes it to our web page. And after that, what we also need to do is we need to give our extension some kind of a unique name and register it with the extension manager. That is something you typically do in your extension file as well. And the way to do that is by calling Autodesk Viewing that. I'm never sure if it's the extension manager. Let me actually go back to our skeleton here. Yeah. So there is a global object in the under the Autodesk Viewing namespace called the extension manager with lowercase t that can be used to register an extension. And you give it some name, and then the second parameter is the class extending Autodesk Viewing extension itself. You'll find the skeleton here on when you go back to LearnForge website, and when you look at the basic skeleton step of our viewer extension tutorial. Right, this is what we're building now without any UI yet. We will get to that very soon. All right. So you can call your extension in any way you want. It could be my company dot my awesome extension, for example. Just a unique string that you will later on use to say that this is the extension you want to load into a specific instance of ForgeViewer. Let me copy this ID that I've chosen here. And the final thing we need to do is going back to where we are creating a new instance of our viewer. You can see in this case, since I've chosen the basic tutorial from the LearnForge website, right? We were instantiating a new the GUI viewer class, which by the way is a subclass of the viewer3d, which just adds some additional GUI options and functionality. We're instantiating it here in the Autodesk Viewing Initializer function. And we're only passing in a single argument, which is the HTML element where we want our viewer to live, right? However, if we look at the document, the API reference of GUI viewer or the viewer3d class, you'll notice that you can actually pass a second parameter, a config object. And you can see here for more details, you can see the same config object in the base class, which is the viewer3d class. And if we look at the constructor here, you'll find information about some of the options you can specify. I'm a bit surprised that I don't see the extensions here, actually. That might be a problem in our documentation, because one of the properties that is available that can be provided inside the config option is a property called extensions. So what I'm going to do here, I'm going to create a new config object that will be passed as a second parameter to our GUI viewer 3D constructor. And I'm going to use a property there called extensions, which will be a list of strings. And here, I'm just going to start with adding one string, and that's the ID, the unique ID of our extension that we have just implemented, the first extension skeleton. And that is it. There are other ways of loading extensions. You can load them on demand during runtime. If I go back to our app here, you can see that the viewer object actually has methods like load or property loaded extensions, where you can see all the extensions that are already loaded into our current instance of the viewer. You can say NOP viewer.load extension, and you can provide the ID of one of the other official extensions provided by the Forge Viewer team. So there is one, for example, called Autodesk, I believe, .viewing, it should be .markup score. And when you do this, this will actually return a promise that will resolve or fail later on. And then if we try and say maybe get extension, there it is, right? So we've got, during runtime, we have loaded an extension called markup score. Now we can call get extension to actually get a reference to this extension, and we can start using it to maybe do something to, show markups. So that's another way of loading extensions. And there is a question in the Q&A: can you load multiple questions by a comma in the array of extensions? Yes, you can, absolutely. So let us try that by adding, we can add one more. So it's actually an array of strings, right? So it's just, you just separate the strings by comma here. Let's see. So there is one, I'm blanking on the name. Let me go back to Forge extensions. There was one called, I think, Autodesk.visual clusters, which was a cool one. Let's see, built-in extensions, Autodesk.visual clusters. I think that was the one. Yeah. So here, if I try and check what are the loaded extensions, it's called, yeah, Autodesk.visual clusters. So let's try, apart from loading our own custom extension, let's try loading one of the built-in extensions as well, one called Autodesk.visual clusters. So now if we run our app again, go back to the browser and reload our page here. For now, nothing is happening yet because we haven't instantiated Forge Viewer yet. But as soon as I click on one of the designs here in my test bucket, you see that my awesome extension is loaded. So this is where we hit the load method, right? Where Forge Viewer calls the load method of my extension. And now we also see the visual clusters, right? Because we, in the config option, we also we included this Autodesk.visual clusters extension as well. All right, can I unload extensions as well? Yes, you should be able to, just by calling unload. I believe that's also, yeah, unload extension. So you can unload them as well if you need to. So here I'm not sure. I believe this should be the actual object, not the string, or maybe the string. So let me try that. So if I decide that I don't need the visual clusters extension anymore. Okay, yeah, so I've unloaded the extension during runtime as well. And one more question: how can I implement the translation element with a snapping function? Okay, that's a bit more that's a bit advanced topic. You can do that too. So for those of you who don't know, Forge Viewer also provides some snapping functionality so that when you're building something where maybe you want to be able to move your objects around, which is also something you can do, you can make the behavior, the interaction, even better by actually snapping to various points on the geometry. That's a bit more involved. Again, we may get to that if we have more time after one of our segments today, but in the meantime, I would ask you to, I would recommend that you go to our blog, to forge.autodesk.com/blog. This is where we often document or provide answers for questions like these, Brandon. If somebody says, okay, I want to be able to move things around and I want to be able to snap to, let's say, corners of my building or to midpoints of my line segments. Many of these we try and answer through blog posts. So for example, here, if you go to our blog and you filter by my name, you'll find that one of the latest blog posts I wrote were about snapping. So here you'll find a quick blog post explaining the process and the viewer APIs that are involved, and it includes some sample code for that as well. So here we talk about how the snapper class can be used in Forge Viewer, and here I'm basically building a custom tool that can draw an extruded polyline where the individual points of the polyline, the vertices, are snapped to endpoints of the geometry in the loaded SVF model. And somewhere towards the end, yeah, we have a link to the code that basically demonstrates the snapping functionality as well. And again, it is actually here in form of a viewer extension right here. All right, and one more question. Is there a way to get a list of objects with their IDs instead of fragments? Oh yes, absolutely. You can definitely do that. Let me go back to my page here. That really depends on what objects you want to retrieve, right? One thing could be maybe you want to get all the IDs of all the IDs of all the objects in the scene, right? That can also be done with the tree instance tree object, right? So if I get the reference to my instance tree, what I can say is tree that get root ID, and this will basically give me the number of the object at the very top. Usually it's 1, but it's better to ask the viewer about it. And now what I can say is I can say tree.enum node children. And what this does is that you basically say, okay, I want to get all the children from the root, from the object ID 1, and I want to print them in the console. And by providing the third parameter true, you're basically saying that you want to enumerate all the children recursively, meaning that for all the children of the root, you want to print their children as well and their children as well. So by doing this, you basically get all the IDs of all the children of the root, right? And we will actually use this later on as well. Then it's up to you, right? Another option is, Eddie, maybe you only want to get the IDs of objects that contain some specific string in them, in one of their properties, right? And for that, you can use something like this NOP search function. So search function, the way it works, we can take a look at the API reference again. If we search for, well, search, you provide string you're looking for, callback function for success, callback function for error. Maybe you can filter it you're only looking for some text in specific property names. So let's try that. In our case, let's say we're looking for anything with wall. Right? We can try that and see console log, console error to see if we find anything. There you go. Right, so very quickly, the viewer found 206 objects that contain wall somewhere inside inside their properties. So, and then you can start, combining everything together with the viewer APIs, and you can say, okay, well, search, and then, instead of just saying console log, I'm going to say DBIDs. That's the parameter that will be called, that will be, include the first argument to my callback function. And what I'm going to do is I'm going to say NOP viewer dot isolate DBIDs, because I remember that the isolate method requires a list of IDs that you want to isolate, meaning that you want to keep them visible and hide everything else. So check this out. Boom. right? So by combining these two APIs, I can very quickly hide everything else that's not, that doesn't have wall included anywhere in its properties. So Eddie, I hope that answers your question. If not, please ask one more time, maybe adding more details on what exactly, what objects. Oh, perfect. We'd like to read there. Awesome. All right, so we've got our extension and we're running a bit over time, but just quickly, we don't need this extension to do anything just yet. We will be using this as the skeleton, as the main scaffolding extension for the third and fourth part of our tutorial today. One thing we can add to there is, let's say for any other extension that we'll be adding, let's say we want to add a toolbar in a button in our toolbar in the viewer that will trigger the extension. It's not strictly necessary. You don't have, your extension doesn't have to add any button there. You could, for example, what you could do is here in the load method, you could say this.viewer, because this is actually set by the super class. You could say add event listener, and you could, do something like listen to selection changed event. And you could, so in that case, you would not have to show any kind of button anywhere to activate your extension. Your extension will just react automatically as soon as you selected something in your viewer, right? But let's say for now that we want to have some kind of button in the toolbar. So one way to do that, the official way to do that, is by adding another method that will be actually called by Forge Viewer called onToolbar created. This is the recommended approach because sometimes, it's not guaranteed the timing of when your extension is loaded, whether the toolbar will already exist, or maybe when your extension is loaded, the toolbar UI in the viewer is not yet available. So it's better to, not try and add anything into toolbar right in the load phase, because again, the toolbar may not be available. Or it's possible that, some other developer is using your extension in just viewer 3D class, not in GUI viewer 3D class. So maybe there will not be any toolbar at all. But for now, we assume that there will be one. And this onToolbar created method is the best place to actually initialize your UI, to add your own button. And to save a bit of time, I'll just point you back to our basic skeleton of the JavaScript extension on the LearnForge website, where you'll find a little bit of UI initialization logic. Let me just bring it here and just explain very quickly what it's doing. So one thing we'll need to do, you can see here, we'll be trying to access two member properties of our class, _group and _button. It's a good practice to define these in the constructor to let the developer know that, there's this class will have some members that will be accessed later on by its code. And what we're going to do here, we're basically always accessing this.viewer, right? This is, again, a better approach. Instead of using NOP_viewer, because that might be referring to another instance of the viewer, it's always better to access the viewer API by calling this.viewer, because that's the instance of the viewer that actually loaded this extension, right? And what we do here, we access the toolbar property of our viewer, and we try and get control with a specific ID, right? In this case, I decided to call it all my awesome extensions toolbar. And if it doesn't exist, we create a new control group. All the UI classes of the viewer are available under the Autodesk Viewing UI namespace. So we create a new control group with that ID, and we add it to our toolbar. Control group, by the way, is every single group separated container of buttons. So we are checking if there is a container with the ID my awesome extensions toolbar, and if not, we create one and add this new separated container for buttons at the end of the toolbar in Forge Viewer. We only do that if it's not available yet. And then we create a new instance of a button, again, give it some ID. These IDs are all used as the HTML IDs for the HTML elements that will be created under the hood. And we can specify some on-click handler, right? So in this case, we can just say hello world. And then a couple more things. We just add a tooltip. So we specify the text that should appear when we hover the button in the toolbar. And we can also add CSS classes. For example, if we wanted to style the button in some way. And the way to use this later on is that if I say, okay, that my button will have a CSS class called my awesome extension icon, I can go back to my CSS or create a new CSS file and create a CSS class for this my awesome extension button, right? And I can specify, for example, an icon that should appear there. The LearnForge website specifies, again, like some of the typical background image. You can specify size is recommended to be 24 pixels, and have the background centered and not repeated. You can either have some PNG icons available in your own source code or bring them from the outside. I actually was looking at some free icons before this segment. I found Icons8 is having a pretty good selection. So what I'm going to do here is I'm going to copy this URL. Oh, it looks like it copied the entire image. I'm going to use it inside this URL link, deleting the HTML markup. Right, so I'm going to bring in a smiley face from some external website. I'm actually going to be a good citizen and add some credits for these guys somewhere at the bottom. All right, so now our extension, as soon as the toolbar is available, will actually initialize some kind of UI, adding a button to the toolbar, which for now, all it does is just saying, hello world. So let's give that a try. All right. Okay, so I open one of my models. We should see a new icon here. There we go. My awesome extension. Now, if I click it, it just says hello world. So this is the scaffolding we're going to be using in the next segments to basically start building extensions that actually do something, right? Start using more of the viewer APIs that I demonstrated in the console to get a list of IDs, hide them, isolate, get properties, create UI. So I think that's enough for step 2. Now I'll give you time to follow along and create your own first basic viewer extension. And I see there's a couple of questions. All right, what is the difference between these two approaches? My awesome extension extends and function call. Okay, good question, Vladimir. Sometimes you may see, instead of just seeing class extends auto viewing extension and constructor, you may see something like function extension, and then something like call this viewer options. It will probably look like this. I've been doing this too many times. And then you would have something like my awesome extension prototype equals something, and then prototype load equals function. This is basically just an old way of defining classes and inheritance in JavaScript. So JavaScript doesn't really have the standard inheritance object model or object inheritance model as C++ or C#, for example. JavaScript used something called prototype inheritance, where you're not inheriting, let's say, methods from a superclass, but you're inheriting functional properties and methods from a parent object. So you can have one object that is defined as a parent of another object. And if on this object you call a method, and it's not there, JavaScript will actually try and traverse the prototype chain, your parents, until it finds an object that has this method that you're trying to call. So that's the old way of specifying, extending this Autodesk viewing extension class. But luckily, with the recent version of JavaScript that's now available in all modern browsers, you can use this more modern and cleaner, in my opinion, syntax, just saying class extends and constructor super. Of course, just keep in mind, under the hood, it's actually doing the same prototypal inheritance, but it's, I think, easier to write, easier to read, right? And that's why it's there. So that I would recommend always using this, class syntax. All right, and one more question. Can we go over how we added visual clusters again? Yes. So again, as I mentioned, Forge Viewer, actually, many of the Forge extensions again, many of the functionality in Forge Viewer is actually coming from built-in extensions. So things like section tool, sectioning, or measure, or probably the model browser even. Most of these are actually extensions that were implemented by the Forge Viewer team and that are loaded by Forge Viewer by default. So here on this forge-extensions.autodesk.io website, if you switch to this built-in tab, you'll see that nav tools, measure, section, BIMWalk, explode, full screen, all of these are implemented as extensions. But not all of the official built-in extensions are enabled by default. There is, for example, snapping, minimap, document browser. That one's pretty cool too. These you can enable, you can either include them in your config here, right? So you can add them as you're creating new instance of your GUI viewer 3D class, or you can load them on demand by viewer.load extension when needed. Document browser, by the way, is a cool one where, if you remember, I was saying that whenever you have an input design like Revit model or Inventor or SolidWorks or 3ds Max design, when you run it through Forge, through the model derivative service, Forge can generate multiple outputs from that one design, right? So in case of a Revit model, it can generate multiple 3D views, multiple 2D sheets. By default, it just takes the default viewable, but you can also control. Sometimes, of course, you want to have access to the other designs or outputs from your Revit model, let's say, as well. And one way to do that is using this document browser extension. What it does is, when I activate it, it should add, there we go, a folder icon here into a toolbar called Document Browser. And when you open it, it will basically get the manifests from the model derivative service for this Revit model, and it will show you all the outputs that were generated, right? So the 3D view, the 2D sheets, and you can switch between them quite nicely, right? So instead of you having to go back to code, finding the right ID of this sheet and changing it in your code, you can just activate the document browser and use that instead. The only problem here is, I think, something we will need to change on this website, on the forge-extensions Autodesk.io, is including the full ID of the extension. Because if I check this visual clusters here, it'll add, actually, sorry, I think I need to be in a 3D model if I want to be able to use visual clusters. There we go. The ID of the extension is actually different, right? I think it's Autodesk.visual clusters. So I think we should probably mention that here, so that if people want to copy and paste it into their own code, that we want to make it easier for you guys. So if I say viewer loaded extensions, yeah, so you see that BIMWalk is called Autodesk.BIMWalk. So it really looks like everything you see here should just be prefixed with Autodesk dot. So Autodesk.visual clusters with uppercase V, uppercase C is the extension that you can enable for your custom Forge application as well. And we do that here by including Autodesk.visual clusters as another string in our config object when instantiating GUI viewer 3D. So I hope that answers the question. Another question, can you add Three.js text geometry as annotation in the viewer? I'm not sure about the Three.js text geometry, but in general, I would answer in a more general way. You can do both. You can insert custom geometry, Three.js geometry, into Forge Viewer. You can definitely do that. And you can also overlay custom 2D content, meaning custom HTML, on top of Forge Viewer. That was the feature I used in the Forge Digital Twin demo to show the annotations. And I'm basically then just using a specific Forge Viewer API to compute the right position for the HTML elements whenever I move the camera. You can actually find the source code for that as well. That might be helpful. If we go to, I have a copy of the project on my personal GitHub account. So if you go to github.com, Petrobras Forge Digital Twin, or you see, you can find it on the Autodesk Forge one as well. This is the complete source code used for that digital twin demo with the Jet engine. And you'll see here in the public folders scripts that I actually have. I read that those extra parts of pieces of functionality, like the animation, the coloring, the heat map, as well as the annotations, I read them into their own viewer extensions, right? And that's what I do here, where basically I want to just find a specific piece of code that I'm using to position the markups. Here it is. Right, so this is a little bit of viewer code that I'm using to basically take the original XYZ position of the problem in the model's XYZ coordinate system, right? And I'm using this world to client method available on the viewer to project this XYZ position from the model space into the screen XY coordinates. And then I'm using jQuery here to set the left and top of my HTML to the position X, position Y, and maybe offset it a little because I'm adding like an arrow there. So this is how you can, add like text or any rich HTML and overlay it on top of the viewer, right? That may make sense in cases where you want the text to be rich in the sense that you want to be able to style it using CSS. You maybe want to include some links that are clickable in the text, right? So for that, HTML overlay makes a bit more sense. But there are also maybe situations where instead of having an HTML overlay, you actually want to include something inside Forge Viewer, like some little geometries, like indicators for some, I don't know, IoT devices or things like that. And maybe if you want to have a lot of those, it's more efficient to include them directly inside the 3D scene and have them rendered efficiently by the 3D rendering engine. For text geometry, specifically going back to your question, Mark, I'm not sure. We'd have to try that. So for the rest of you, Forge Viewer is based on an open source library called Three.js. Three.js. It's using the same, basically WebGL standard under the hood to render 3D graphics on the web. The one thing a bit unfortunate is that when Forge Viewer was first implemented, Three.js was at version 71. Now you can see that Three.js is at version 121, and the Forge Viewer sort of got stuck, started lagging behind. The reason for that is back then, when Forge Viewer was conceived, it was built on top of Three.js, but unfortunately, Three.js library was not extensible enough for us to be able to, follow along with the development of Three.js. We had to actually take some parts of the Three.js logic and replace it with our own to optimize it, to be able to render really complex scenes with our custom shaders and everything. So unfortunately, that's the reason why, as the two viewers evolved, Forge Viewer and Three.js, the longer they were staying apart, the more difficult it was to bring them back together. So right now, if you want to use Three.js functionality inside Forge Viewer, you'll need to make sure that you use 3JS documentation for 3JS version 71. And 3JS, again, here it allows you to do things like create custom geometry, add it to the scene, create custom materials, custom shaders. You can do all of that inside Forge Viewer as well. The only thing, again, disclaimer, you need to make sure that you're working with 3JS version 71. And again, going back to, do I have the blog here? No, I don't. Yeah. If you go back to the blog and again, try and look for maybe topics like maybe to Forge Viewer. Where is the viewer here? You may find tutorials on, for example, adding custom models to Forge Viewer using 3JS. And we go into more detail on that in the blog. Let's see if I find it here. So here's one example. There's a blog post on, for example, creating a custom 3JS material that you can then apply to your Forge designs, right? So this could be helpful. For example, if you wanted to implement some sort of a heat map, not by adding custom geometry, but just by coloring some part of your Revit model, let's say, based on some criteria, right? So this blog post explains how you can create a new 3JS shader and material, right? And here we have another one called, explaining how you can add custom geometry in the scene as well. Right, one more question. Is there a way to extract the model metadata after you translate the model and know what object has been added or modified or removed? Yes. Okay, so, all right. Good question, Abi. Being able to get the metadata, you can get the metadata in all sorts of ways, right? You don't even have to use Forge Viewer if you don't want to. And I think I have a blog post on that as well. Talking about the different ways. I can actually delete, it's probably without the viewer. Metadata without the viewer. So there are a couple of ways. The official model derivative service offers an endpoint that you can use, exactly the one you're mentioning, that you can use to get the JSON with all your properties, right? That was, by the way, the same thing we expose in this in our Visual Studio Code extension. If you right-click one of these things and say, or maybe the 3D view, and say view derivative properties, this is basically just making a request to that Forge model derivative service endpoint, and it returns the properties in this shape, right? So it's a JSON with, again, the object ID. Those are the numbers we're using in the viewer APIs, and all their properties, right? Another object and all its properties, another object, all its properties. That's one way to get the metadata. You can also, if you're a hacker, you can also get the same data in a SQLite format, because when the model derivative service starts extracting data from your, let's say, Revit model, the 3D views, 2D sheets, thumbnails, it also stores the metadata in a SQLite file. And you could find it if you were to look inside the manifest, model derivative manifest for your file, and look for an asset with the role Autodesk Cloud Platform Property Database. And it will be a file, most likely with an extension SDB. This is a SQLite file that you can then download and open with your own favorite, SQLite tool, or in your custom code using SQLite library, for example, in Unity, if you wanted to. And then third one, you can also retrieve the metadata in the format that is being downloaded and read by the viewer. It's a collection of gzip JSON files, and we explain more, like how it can be parsed and how you can start querying the data from there. But the other part of your question was if you can detect like changes to objects between versions. If we're talking about detecting changes to properties of individual objects, you could do that as well, or changing, or maybe somehow being able to detect if objects have been added or removed. That could be done. It will be a bit more work, but it could be done. Just be careful about one thing. These IDs that we keep using here, right? These, like in this case, number 920. These numbers are not guaranteed to be the same in the next version of your Revit model. So if I got another version of this design from Revit and I ran it through Forge and I tried selecting the object ID 920 in the next version, it may not be the same. So these IDs, unfortunately, we cannot guarantee that they are persistent or stable, meaning that they represent the same things in another version of a model. But we do provide tools where possible to help you actually be able to identify if a piece of an object in two versions of a design is the same thing. And we introduce this concept of external IDs. So if I get properties for this specific wall, 920 console log console error, here we are. You will see an external ID, some external ID. Now, the shape of this external ID will be different depending on what kind of file was on the input, right? For Revit models, you will get the Revit GUIDs. If you have an Inventor model, you will see like a slash separated path in the instance stream. If you open an, let's say we can try an F3D file. You can try selecting one part here. If you say get selection and get properties, let's say 27. You can see that here, in this case, in case of a Fusion model, the external ID will be represented some other way, some magic string. But this is something you can rely on being stable across, persistent across versions of your design. So if somebody gave me another version of this XARM F3D file, and I wanted to somehow check if some property changed or if some element was added or removed, I could use the external IDs to match the same objects between the two versions. Okay, so I hope that answers the question. And with this, I'll give you some time to work on the second step to implement your extension. We went a bit over time, so you'll have roughly 48 minutes before we meet again at 1 p.m. Central European time. And then we'll start working on, we'll make a copy of this extension skeleton and start implementing new extension that will work with some of the main, like the typical viewer APIs, working with isolation, selection, things like that. All right, so I'll see you then. All right, we're back. Welcome back, everyone. Still seeing strong participant numbers. So there's a couple more minutes. I'll take a couple more minutes to see if there are any pending questions for step 2 when you were building your first basic extension or skeleton for a viewer extension that we will be reusing now and in the final segment today. And if there are no questions, we can move to our first extension that actually is doing something with the viewer. What we'll do is we'll just copy and paste the skeleton of the viewer extension we implemented in the second segment. And this time what we'll do is we will use the viewer APIs to get the list of all selected objects, their IDs. We will iterate through this list and we will retrieve properties of each object to retrieve the external ID. And we will show a prompt in the browser asking the user if they want to isolate this specific object or not, showing the external ID. And for those IDs that the user confirms, we will just isolate them, meaning that we will hide everything else and isolate just these objects with these external IDs that the user confirms that they want to hide. All right. So what I'm going to do is I'm going to go back to my source code here, and I'll make a copy of my awesome extension. And I'm going to call it, I don't know, let's say isolate extension. Or maybe again, I should maybe use naming consistent with the LearnForge website. So let me take a quick look here. If we go to handling selection, step of our viewer extension tutorial, okay, so here the file is called handle selection extension.js. So let me rename it. Use the same name. All right, we've got our basic extension ready. Let me just rename the class as well. Actually, okay, so let's see what is it called here? Handle selection extension. I'm going to rename my class, update the logs in the load and unload function, and I'm going to use a different extension ID at the bottom when registering it as well. We could probably use different names. Well, we will keep the toolbar ID because let's say for now, we will want to put all the buttons for all our extensions in the same group in the viewer toolbar. So we can leave this part as it is. But here, as we're creating a new button, we can probably give it a different name. And again, to keep things consistent with the tutorial, the LearnForge website, we will copy the name of our new button from here. So it's called handle selection extension button. That's a mouthful. All right, and we will add a CSS class to our button called handle selection extension icon. Okay. Take the strings from the LearnForge website. Right. And maybe, you know what, let me remove the my company from the ID as well so that things are consistent. So we just say, right now we register our extension under a unique ID, which is the same name as the class itself. But again, it's up to you how you decide to name these, define these extension IDs. All right. So we've got our handle selection extension, and we will include it again into the config when creating new instance of our viewer. I'm going to add another string here called handle selection extension. Oh, and I must not forget to actually bring the JavaScript into our HTML, right? So that class for the extension is actually loaded and available in the global scope. Say JS/handle selection extension.js. So these are always the 3 steps, right, that you'll want to do when building an extension. Implementing the class itself with the registration, right? So preparing the JavaScript code, loading your code bringing it into HTML. That's the second part. And third is including the extension name when creating our viewer, or loading it later on using viewer.load extension. Those are the 3 main steps. Now we will also want to add another icon to our new button in the toolbar. So I'm just going to copy the CSS class from our new extension class. So here it's called handle selection extension icon. So I will add a new CSS rule for this class. I'm going to reuse the same properties for the background that we used in the original extension skeleton. All right, I'm just double check it from recording, and I'm going to go back to icons 8 to find some nice icon you may want to use there. So I'll try this one. This one looks cool. Copy the URL. I'm going to have to remove the HTML markup to only keep the URL of the picture. All right. Now if we run our app, let's see, we should now see two buttons in our new container, my awesome extension that just says hello world. And for now, handle selection extension that also says hello world. That works. Now we're finally getting to the part where we're about to start implementing the custom behavior leveraging the viewer APIs. And we can, let's say for now, we want to trigger this custom logic not on selection changed or any other event or keystroke, but for now, let's say we want to run our custom logic when we click the button in the toolbar. So what we're going to do here, first of all, we're going to use one of the methods that I mentioned earlier called this.viewer.getSelection, right? This is one of the methods documented in the API reference on the Forge portal. And we'll use it to, let's say, get a list of selected IDs of the selected objects, right? And now, after that, we can say viewer.clear selection to actually deselect everything in the scene. And then you can say if dbid's length is non-zero, so if something was selected, we can do something, otherwise we'll have a fallback here. And what we'll do is we can say for const dbid of dbids, the standard for loop in JavaScript to iterate over all the numbers, all the object IDs that were selected. And we will do something with them. Otherwise, if nothing was selected and we click the button, we can say just this.viewer.isolate nothing. This should basically help us. Okay, if something was isolated in our scene, meaning some things were hidden, by calling this viewer isolate with empty array, that this should help us basically recover everything and show everything. But if something was selected when we click the toolbar button, let's say we will want to get the properties of each object in here in the list, and ask the user, show a prompt to say if they really want to isolate this object. Let me see here. So this is kind of like what we're going to be building now, right? So we're going to iterate through the list of selected objects. We will get the properties of each of those objects, get their properties, show the external ID and the name of each object. And if the user, you see here, we're calling if confirm, right? So this will basically just show a yes, no prompt in the browser. And if the user confirms with a positive response, we will add this ID to a list of some IDs that we want to isolate later on. Or we call isolate 0, which should have the same effect as not isolating anything. All right, so what we'll do here is we're gonna follow the same logic used on the LearnForge website. We're gonna start an empty array called isolated, where we're gonna keep track of all the IDs that the user confirmed that they wanted to hide. And inside here, for each ID, we're gonna say this viewer.get properties, another method that I already mentioned in the second segment. We're gonna be asking about properties of a specific DBID. Props, here this is the fat arrow syntax. I'm basically providing a function that will be called later on when the properties are available to us. The viewer will call this function, and inside we can define the logic, what should happen next. We will say if confirm something like, what do you call it here? Isolate name, let's say props external ID. So you can just ask if you really want to isolate this specific object with its name and external ID. And if you do, we add this ID to the list of to the list of isolated. All right, and we can immediately call isolated. So this is not strictly necessary because this means we will be calling isolate every single time we get a confirmation from the user. So you could potentially call this just once later on. You just need to make sure that when you start dealing with asynchronous calls where maybe you would want to wait for until you get the confirmation about all the different IDs from the list before you call this viewer that isolate anything. All right. So let's review that one more time. We get the list of selected IDs of selected objects. We clear the selection. And if the selection was empty, we just remove any isolation state. And if the list of selected objects was non-empty, we iterate through them. For each selected object, we get its properties. We show a prompt in the browser asking if the user really wants to isolate this specific object. And if they do, if they confirm, we just keep adding these IDs to the list of all IDs to be isolated, and we're calling the viewer.isolate function to actually handle that state change. All right, let's give it a try. All right, let's try that. So let's say I select the roof and one of the walls, and maybe this other wall as well. All right, so now if I hit handle selection, so see now, so this is the confirm call, right, in our code. Now the browser is asking me if I want to isolate this object with the name basic roof and with the external ID, in this case, a Revit GUID, I say, yeah, I want to isolate the roof. Now it's asking me if I also want to isolate this basic wall number 427092 with this Revit GUID. Maybe now I'll say, no, I don't want to isolate this one. And now it's asking me about the third part, the third selected object, another basic wall. If I want to isolate this one, I'm going to say yes. And in that case, I would imagine, yeah, these two elements should remain visible and everything else should be hidden. This is the effect of isolation, right? When you say viewer.isolate something, what happens is that it'll build a list of IDs of things that should remain visible, isolated, and everything else will be hidden, or at least rendered with this semi-transparent effect. You can control, by the way, the effect of the hidden objects using the settings in a toolbar. So if I go to configuration and display, you can see here that I have an option called ghost hidden objects that is enabled. If I disable it, it means that anything that's hidden will be just completely hidden, not even rendered as ghosts. Yeah. Well, yeah, and that's it. You can, of course, customize the logic in any way you want, right? So instead of us asking the user for every single, to confirm every single object that was selected, whether you want to isolate it or not, again, you could maybe customize this logic to do something slightly different. Maybe, again, like only isolating objects that contain certain texts in their properties, right? So one thing we can try, if I go back to my viewer and I right click and say, show everything, let's try something. I'm going to select this wall and look at the properties, right? Just to explore. I'm curious what kind of metadata was extracted by Forge. What's happening? For this Revit model. So let's see, we have some constraint information, structural information, identity data, or maybe materials, right? So, okay, so how about this? So the material of this element is timber, right? So what if I say that instead of asking the user, maybe I'll change my logic here. And I'm going to say, when I click on my extensions button in a toolbar, I will want to isolate every element that has timber in somewhere in their properties, right? Maybe I want to filter by like material type. In that case, what we could do is, okay, so instead of calling selection, we're just going to say is the viewer search. And again, this is the method we were looking at earlier here, where you specify the text, callback in case of success, callback function in case of an error. Optionally, you can filter the property names that you want to look into for this string and some additional options. For example, if you want to search through hidden properties as well. All right, so we're going to say timber. And on success, we expect that we will get some search results. Now, so now this is the situation where maybe I don't know the exact structure of the data that I will get in my success callback function, right? So I don't have to worry about that. I can go back to my app and see the results directly here. So if I type nopviewer.search, I'll say timber and console log, I will see exactly the shape of the object. Oh, not timber. There we go. Right, so I see that the response to this will be a list of IDs directly. So it's not going to be any other kind of JavaScript object. It's just a list of IDs. Perfect. So now I can go back here and assume that the callback will, the parameter, the argument that will be passed to my callback function is just a list of database IDs. And here, very easily, I can just say is viewer.isolate DB-IDs, right? So if we reload our app,
I didn't get that. Could you try again?
That's Siri talking to me. All right, so let's try that now. Oh, okay. So only this is timber? Interesting. I thought it was the other, this other wall was supposed to be timber as well. Let's try it again. Properties, material, timber, it's there. Oh, so why wasn't it included? 2590. All right, so if I go back and let's say I will also want to log all the DB-IDs into the console. Timber. All right. My laptop fan is spinning up. Crazy. Not sure what's going on here. All right, let's try one more time. 2, 5. Interesting. So it's not included here. Not sure why. If I look at the properties of this one, do I see timber here as well? Ah, okay. So I'm wondering if, okay, so maybe it's not looking into all properties. All right, so this is something I'll need to look into. I'm not sure now why the search is not returning the other elements as well as matches, like the 2590 wall. For some reason, the search doesn't find it there. Anyways, I'll look into that. And for now, I would probably leave time for questions if there are any. Anything related to the APIs, the viewer APIs that we're using here. And in the meantime, I'll probably look into this bit more and debug the search functionality. Okay. So are there any questions? If not, you'll have some extra time, again, roughly about an hour and a half to start experimenting with your second viewer extension today, leveraging the viewer APIs like the get selection, clear selection, isolate, or get properties, or those standard ones. And again, if you want to move ahead, you can always go back to the API reference and start looking at some of the other APIs available on the viewer 3D class and see if maybe you want to change colors of things, or I don't know what other, I can't think of other good examples of things you might want to do inside viewer, maybe hiding nodes or adding custom geometry. So feel free to experiment on your own as well if you want to, again, try some more stuff, more than what we're covering right now in this step 3. And if not, unless there are any other questions, I will pause the recording. There is a question. There is a question. I'm struggling to get the icon showing in the toolbar for handle selection extension. Trying to find out why it's not showing up. So one thing you'll want to check. Now, give me a second. One thing you'll want to check if your toolbar is not showing any toolbar button is not showing any icon is just make sure that basically in your code and in your CSS that you're referring to the same thing, right? So in this case, in my code, I decided to add a CSS class to my button called handle selection extension icon with uppercase S, E, and I. This is the CSS class you will want to use in your CSS file if you want to customize the appearance of that button, right? So in my CSS, I added this dot and the name of the class that we've added, right? Maybe this might be a bit, this might be prone to typos. So maybe in your code, you can just call it, I don't know, here. You can just call it my icon, right? And now you can change the class to dot my icon, or the rule in your CSS file. You can say dot my icon, right? And again, what you want to do is specify that it's 24 pixels, not repeated and centered the background image, and some kind of valid URL pointing to an image that you want to use as the actual icon on the button. So double check that, again, you're using the same class name, both in the CSS and in your code. All right. And there was a comment or question or comment. You can search directly for special attributes as 4th parameter. Yes, you can. When using the search, that was also mentioned here in the API reference. The fourth parameter, you can specify an optional list of attributes that you want to search through. So we can experiment with that as well. And let me just, let's say that we want to compute the summary for all the objects in our scene, but not necessarily for all the groups or high-level nodes, that we only want to compute the summary from the low-level, the individual elements, selectable objects in the scene, meaning objects that don't have any other children. So we will somehow want to collect this list of IDs of objects that don't have any other children. We can use the instance tree structure for that one I was also teasing previously in one of the previous segments today. You'll also find more details on that on the LearnForge website. Let me see here. We have this section called enumerate leaf nodes. So this is basically what we're doing is we're getting the instance tree, or here it's called object tree. And when it's ready, we call this enum node children. That is one of the methods of the instance tree that I was showcasing earlier. We start from the roots, and for every DBID, and we set this third parameter to this enum node children method to true to make it go recursively to all the way down through the entire hierarchy tree. And for every DBID we find along the way, we use the tree as well to get just the number of children of that specific object, right? And if it's 0, we know that this is a leaf node, and we will store it for later use. All right, so let's try that in our code. We will put that logic for collecting the IDs of all the leaf nodes in our model into a separate method to keep things clean. So let's call it something like get leaf nodes. So what we're going to do here is we're going to get the instance tree object. There's a couple of ways you can use the viewer.getObject tree, or the approach I was using earlier today, which is this.viewer.model. So this means this is the latest model that's been loaded into the viewer. Get instance tree. Right. Now what we're going to do is we're going to prepare a leaves, let's say, array that we're going to populate as we're traversing through the instance tree. I'm going to say tree.enum node children, starting with tree.getRoot ID. And then for each DBID we find along the way, we will want to execute some function, run some callback. And the third parameter true, set to true, means, again, the entire tree will be traversed recursively. So with our callback, what we're going to do here is we're just going to say if tree.get node child count for a specific DBID. If it's 0, we will add it into our list of leaves, right? So those are the DBIDs of objects that don't have any other children. Okay. And yeah, I believe that's it. And from here, we can just return leaves. So this is a synchronous method. And the other one will be, let's say we're going to prepare a function a separate method that will compute the actual summary for a specific type of property. Or multiple properties, actually, that we want to compute the histogram data for. Okay. So let's try that here. All right. So in our onClick event handler for our button in the toolbar, we're going to just store the leaves. There's that get leaf nodes. for now, we can just try and log them into the console, just see how it's working. All right, if I reload the page here, I select one of our models in Forge and hit the third button. You see we have 439 IDs that we've identified as leaf nodes, meaning objects that are not groups of other objects that have no other children, right? So for these, we will now use a slightly different method on the viewer 3D object to get not just properties of a single object, but to get specific set of properties for a large set of objects in our model. With that, you can take a look at the, actually, sorry. I'm not going to go exactly the same order as the tutorial on the Learn4 website, but I don't think that's really needed. Here, the one thing I wanted to bring to your attention is, instead of calling viewer.getProperties with a single DBID, you can also call viewer.model.getBulkProperties. And in this case, the first parameter is not a single number, but a list of IDs that you want to search through. And you can also, as a second parameter, specify a list of all the properties that you actually want to retrieve from that list of objects. And then items is basically going to have the results of the complete search or the property retrieval. So regarding this viewer.model, right, accessing the model object, again, for now, we're assuming that in our viewer, we're only loading one model at a time, even though it's possible to actually load and aggregate multiple models at the same time. But for now, we're assuming that there's just going to be one model. So calling viewer.model is fine, because we know that that model property will always refer to the model that's been loaded into our viewer. And you can find the documentation for the model class on the Forge portal in Forge Viewer documentation as well. So you'll see here, these are the methods I've already been using, right? The get instance tree to get access to the tree we can actually use to traverse the tree, get the number of children of individual objects, get the fragments attached to individual objects and things like that. We can use a couple more options here. Check if it's if it's a 2D or drawing or a 3D model, if it's the new SVF2 optimized file format, units, metadata attached to the model itself and things like that. And here you also find the get bulk properties. So instead of calling viewer.getProperties for an individual object, we will call on the model instance, we will call the get bulk properties, providing a list of IDs of objects that we want to get the properties from, providing, here, okay, so it's in the options, providing options with prop filter. So we're providing a list of strings specifying the properties from which we want to extract the values. This is optional, so if we don't provide it, the viewer will give you all the properties of all the DBIDs that you specified. So we will filter that to make it more efficient, to only really extract the type of information that we're interested in. All right, and then success callback and error callback as usual. So let's try it here. So let's say, we can probably, for now, we can probably put it in the onClick event handler. So we now have the list of IDs of objects that have no other children, right? And what we're going to do is we're going to call your model.getBulkProperties leaves, right? So now we're basically saying, yeah, get us properties of all these DBIDs, or all the objects with these IDs. The second parameter, we will use the prop filter option. It's something that's being used, I believe, here as well, although this is interesting. This is using the filtered props at the top level. So this should be prop filter set to some properties that we want to extract. So this is now something that you will want to customize for your specific use case, depending on the types of models that you're computing the summary for, right? So in my case, I'm using a Revit model here. So what I'm going to do is I'm just going to try, again, I'm going to say selection. I'm going to get the properties of this 2590 object. And I'm going to just pick one of the properties here in the list that I will want to compute the summary for, right? So let's see what would be a good area and length are probably not a good good example because there will be a lot of different values, but maybe something like level, maybe level could be a good candidate for something we may want to compute the summary for, or maybe manufacturer, although there doesn't seem to be any data there. So Keynote, mark, comments, type name, enable analytical model. I'm just trying to see which one we could. So maybe we can try base constraint for now. So let's say for now, we're only going to look for the summary of all objects and their base constraint property. What appears in this base constraint property across all the leaf nodes in our model. I'm going to keep a record of my props here in a constant. And I'm going to say prop filter props. So with this, I'm saying, okay, I only want to extract the values of the base constraint properties for all these leaf objects. And in case of success, we will want to execute something, do something. And in case of an error, we'll want to, let's say, log an error to the console. All right. So for now, what we can try is, again, just to implement these things step by step and making sure that everything is working as expected. For now, what I'm going to do is, instead of computing any summary, I'm just going to log the output we get from the get bulk properties call into the console, right? So let's try that now. So now if I hit that third button in the toolbar, it should again collect all the IDs of all the leaf nodes, and it should retrieve the base constraint value for all these leaf nodes. There we are. So it's a list of objects, and each object will include information about the DBID that was included in the list when calling this get bulk property method, and the properties retrieved. So you can see here for some of the DBIDs, we'll see base constraints set to level 1 or level 2, or I don't know, there's probably going to be just these, or maybe undefined, or we'll see. And we can experiment. We can always go back and start, changing the list of properties we are extracting for the summary to something else to see, just, out of curiosity, to see what we get. All right, so this is working fine. So again, what we get in the items is a list of objects where each object has a DBID and properties list. Okay. So now the part when we actually compute the histogram, right? So let's do something like this. I'll say histogram is going to be an empty object where I'm going to keep at the top level, I'm going to keep the property name that we're computing the summary for. And inside that object, I will keep key value dictionary of the specific value of that property and how many times it occurred. So bear with me. Okay. So the property will have display name, display value, display category. We don't have to worry about the category. We just want the display name and the display value. All right, so we know that items is a list of objects. So we're gonna iterate it like so. And each item, we know that each item contains a DBID property and properties property, which is a list of another list of objects, right? And we will be checking those as well. So basically here, what we want to do is we want to, because later on, if we maybe specify multiple properties that we want to extract, we will have to iterate over those as well. So we'll have a nested loop that goes over all the properties that we are extracting, right? So in this case, I'm just going to say for each prop of the list of property names. And what I'm going to do here, properties, I'll see if I can find a property with this display name. So I'm going to say from item properties, I will try and find, oh wait, actually, no, I don't have to do it this way. So what I'm going to do instead is iterating over the properties of the result object. So this way, item.properties, we will actually be iterating through all these results. So in this case, there's just one, right? But if we start filtering and requesting multiple properties, this list may be longer. And inside here, we will look at the display name and display value. Yeah, that's what we want to do. All right. I'm going to say display name, display value equals prop. So what we do here in this line, if it's new to you, we're basically using this functionality in JavaScript called destructuring, where instead of saving the display name property into a variable and then saving display value property of the prop object into another variable, we simply destructure it immediately. So from now on, we have two constants one called display name and one called display value. And these have been basically extracted from this prop object. I think we could even destructure it in here. So this is even fancier JavaScript code, destructuring the individual items that we're iterating over in the item properties list. But I can just keep it like this for now. So now, first thing we're going to do, now we're going to start populating our histogram, right? So we're going to say histogram display name, because we need to make sure that this histogram has the keys here specified for the individual property names that we are extracting, right? So we're going to say histogram display name equals histogram display name or a new empty object, right? So this is just to make sure that, for example, we will have constraint object created dynamically, right? As we're going through the data that we retrieve from the getBulk properties call. All right, and then second, we need to check that for a specific display value that we have some number. So it's going to be a number if it already exists, or we will assign it number 1, right? So that means basically for base constraint, in this case, we make sure that we have an object like so. And then inside here, we make sure that the display value, let's say level 1, is set to some number, right? So if there's nothing, we set it to 1. Okay, let's see. So we can do it this way. We can try just post increment like so. That should work. We can give it a try. So basically, with this line, we make sure that we have a base constraint property with some object under it. And then with this call, we make sure that we have a nested property based on the displayed value set to some number or to number 1 if it doesn't exist. And then, actually, no, that's wrong. Okay, sorry, I'm getting a bit. All right, so if it doesn't exist, if this level 1 property does not exist, we will set it to 1. Otherwise, we will set it to, we will increase it. Yeah, we can probably keep it like this. Okay. So let's give that a try. So this should be enough. And then after we're done with the get bulk properties, let's see, I can try something. Then we can say console log histogram. All right. So let's see if this works. So now when we hit the button, the third button in the toolbar, we should request the base constraint values for all the leaf nodes. And we should have a histogram object that will contain the base constraint property. And inside that object, it'll have level 1 number of occurrences, level 2 number of occurrences, and any other property values that may appear there. All right, so let's see what we got there. Oh, okay, there you go. So you see, this is our histogram. So from all those 400 something objects, the leaf nodes that we found, the base constraint was only found on a subset there, right? And from those, one of the objects had the base constraint set to ceiling, one object had the base constraint set to foundation, and let's say 27 objects had the base constraint set to level 2. So that seems all right. So now what we can do is we're gonna go back to our summary extension JavaScript file, and we will create one more class here. We're gonna create our own property panel subclass. So we can call it, I don't remember, what is it called in here? Okay, model summary panel. So we're creating a new class, model summary panel, which extends Autodesk viewing.ui property panel. We don't really need to customize anything here inside this class for now, because we're just going to use its functionality as it is. And the only thing we will want to do is go back to our API reference and look at the documentation for property panel, just to see what are the parameters that will be passed inside the that have to be passed inside the property panel constructed, right? So we have a parent container, some ID, some title, and optional settings for property panel. Okay, so what we're going to do is we're going to say constructor, and so it was the parent container, ID, title, and some options. So all I'm going to do here is just pass these along to the parent constructor. I've noticed on the LearnForge website that we're actually adding one more argument to our constructor for passing in the viewer. I don't really think that this is needed for now, because we're not going to be accessing the viewer functionality from within the property panel class or from our property panel subclass. So for now, I'm just going to leave this out, and we can always, if we need at any point to access the viewer API from within the property panel, we can just pass it in the constructor as well, but I'm not going to do that for now. Okay. And now what we need to do is basically just create a new instance of our summary panel in our on-click event handler when we have our results available. And we can choose where we're going to do that. So for now, we're just outputting everything into the console. So what we're going to do instead, what we can do instead is what I'm going to do, I'm going to create an instance of the panel outside of the button click handler. So I'm just going to add one more property to my model summary extension called, let's say, _panel. And when the toolbar is created, I'm going to create a new instance of the panel here. And it's going to be new model summary panel. And now we want to define the HTML container where the panel should be placed. And typically that is the viewer.container. So we're basically saying, when you access viewer.container, that's the div element in which the viewer itself is hosted. So by saying this.viewer.container, we're basically saying we want our model summary panel to be attached to the same HTML div. We give it some unique ID, so we can say summary panel, and we give it some title. So maybe let's say something like model summary. That's it. Right, so we will only create our panel instance once, and we're just going to be toggling its visibility depending on our state here. So now let's see what we can do. So the panel offers a couple of methods like is visible or set visible. So that's what we're going to be doing here. So we can say something like, if this.panel, or the other way, if our panel is not visible, then do something. Otherwise, set visible false. Right, so we're going to say run some custom logic only if the panel is not visible. And ultimately, set the result to set visible true. Okay, and now the last piece that's remaining is we want to actually take this histogram data that we've computed here, and we will want to insert that histogram info into the property panel as key value entries, right? And for that, we can use another method on the panel called add property. And for that, what you do is you specify the property name, property value, and the category in this order. So what I'm going to do here, I'm going to go through my histogram and iterate through the results. I'm going to say for, let's say, category of object keys histogram. So this is basically iterating through all the keys of our histogram object. And for each category, I will, so actually I'm going to call it prop name. And for each property name, I'm going to iterate over property value, the actual value of the property name that we are computing the occurrences for. So let's say histogram. And in here, we're going to say there's the panel add property. And again, the order is some key, some value, and some category. So we're going to say on the left side, we want to show the property value That's the one that we're counting the occurrences for. On the right side, we're going to show the actual occurrences. So that's value and category. We're going to use the property name itself. All right, and then that's pretty much it. And I think we should be able to use, I think it's remove all properties. So I need to check that. Let me put a debugger statement here. All right, let me go back to our app, reload, and test our fancy new extension. All right, so now our histogram is populated. Now we start iterating over its keys. So at this point, it's just the base constraint, property name. And we start iterating through well, actually, sorry, this was a typo here. There should also be object keys. We want to iterate over all properties of that nested object as well. Okay. So now we're looking at the property value level 2, and we are creating a new property record in the panel with level 2. This will be some number, and the category in which the property will be stored in the panel will be base constrained. Now, one thing I wanted to try was the panel remove all properties. Okay, that's the one I wanted to try. So there you go. See, so we have our draggable, resizable panel, custom panel called model summary, where we're displaying the histogram, the summary results, showing how many objects leaf nodes in our model have base constraint set to level 2, level 1, ceiling, or foundation. But of course now, we should also make sure that we remove the properties when we recreate, repopulate, recompute the summary. So what I'm going to do here, I'm going to say this._panel dot remove all properties. And yeah, and here we toggle the visibility of the panel to make it visible. So that's it. So now let's try something. Let's try some other property that we can maybe try and compute a summary for. I'm wondering, maybe function. Let's try function. So now let's say we will want to compute summary for base constraint and function properties of individual objects. All right. There we go. See, okay, so we've got our results here. So we've been able to find 42 objects that have function property set to interior, 21 objects set with the function property set to exterior, etc. So here's our summary. And I believe that is it for our step 4. Are there any questions? So this is a final segment of our tutorial today. So I would encourage you to now try and follow along and implement this kind of functionality in a viewer extension as well. And again, I will stay here for roughly an hour, I would say. So right now it's 3:30 p.m. here, so until 4:30 p.m. So I would stay here to answer any questions you might have for this final piece, if you run into any problems along the way. before I let you go back to this, to implementing this final step of our tutorial today, just let me go through some wrap up information here. We have 2 more days and 2 more trainings to go. Tomorrow I'll be doing 1 more webinar on dashboards, where we're going to show you how you can start actually combining the viewer, Forge viewer, with additional visualization libraries, third-party libraries like charts.js, for example. And on Friday, my colleagues will lead a webinar on the design automation service in Forge. I also want to mention that today we will be running a coffee break. So coffee break is another event, Forge event that we're running, I believe now every 2 weeks, always on Wednesday at 5 p.m. Central European Summer Time Zone. This is where Augusto, my colleague, and a couple more Forge advocates basically join a call with our customers and talk about what's new, what's coming, what's been, what's changed. And we're trying answering questions if there are any about roadmap and the current situation in the platform. So if you're interested, I would encourage you to head over to our blog post that talks about this Forge event, and there is a registration link at the end. All right. So right here at the bottom, we'll have this image. It's clickable. It's a registration for a Zoom webinar so that you can join us at 5 and see what's new in Forge. Okay. And getting support after this event, as usual, we're very active on Stack Overflow. We're trying to be as active as possible on Stack Overflow, answering your questions. We consider this to be one of the official support channels, either Stack Overflow or using the official email alias that I'm going to type again into the chat. It's forge.help@autodesk.com. You can also feel free to contact me directly on my Autodesk email address, petter.bras@autodesk.com. Just a disclaimer, I may not be able to get back to you immediately because, again, with these type of events that we're running for our customers, we're pretty busy, and we cannot guarantee that we will be able to answer immediately. So if you have an urgent problem or technical question that you need help with, I'd recommend that you go to Stack Overflow or to the official forge.help@autodesk.com email address, because that way, if I'm busy with other events, my colleagues can step in and help you instead. All right. And finally, I would also like to ask you for your feedback, as I was saying yesterday. This is a very relatively new kind of event, this Forge training webinar, and we are trying to really make sure that we deliver good, high quality content. So if you've had any issues with the format of the event or the content or the presentation, please let me know. All feedback is welcome. You can either, again, email me directly on petter.bras@autodesk.com or tweet at me at @ipetterbras on my Twitter handle. Again, we want to make sure that you are really happy with these learning experiences. Now, at least these virtual ones, since we cannot really meet face to face. Okay, that is it for our webinar today. So let me go back to our slide here. Maybe this one. And now is your time to shine. So again, I will be here until roughly till 4:30 p.m. So for the next 45 minutes, I'll be here to answer your questions related to this final step of the tutorial today. So I want to make sure that all of you are able to build some cool extensions to the viewer, build some cool functionality added to the Forge app, your Forge application. Okay, so with that, let me stop the recording. And